Hello, we're going to take a look at what I'll call the boat problem for related rates. Let me grab a couple colors here. So this is another kind of problem. Let me read it for you. A boat is pulled to a dock by a winch that is 12 feet above the deck of the boat. The winch pulls the boat at 4 feet per second. What is the speed? I guess that should be a new sentence. What is the speed of the boat when there is 13 feet of rope out? Okay, so the first thing to do is visualize the scenario. And once you kind of have it visualized, you draw it. So I'm no artist, but this is not a difficult one to draw. Here's the dock. And usually the dock is above the water, so let's put the water here. And then you'll have a boat that's floating on the water. Well, maybe this isn't quite to scale. Like the dock probably wouldn't be that high, but here. Here's a boat. So a winch, that would be like a crank that a rope is on so you could pull the boat in. And it says it's 12 feet up, so that's pretty high. So let's say it's on some metal pole, and up here is the winch. Here's the turn crank, right? Might be mechanized or motorized. And then there'd be a rope that attaches to the boat. So the rope's going to come off of the winch, and it'll attach to the front of the boat. So we need reference points. So you're going to be focused on what the rope is actually attached to. So this will be the point where the rope is attached to the boat. This will be the point where the rope leaves the winch. And then we would connect the two. Right? Now this is the deck of the boat. See the deck of the boat? So it says this, and we're going to go from where the rope actually is leaving the winch. It says it's 12 feet. So this is 12 feet right here. And that's permanent, or in other words, constant. And no matter where the boat is. So here, let me draw. I don't want to mess the picture up. Here's the deck in the water, the deck in the water, the deck in the water. So at first the boat is way out here. And then I pull the boat and it's getting closer and closer. And we got our winch here. So this distance is always 12. See that? When you're doing related rate problems, you have to be thinking of the movie, not a snapshot, not just the picture I draw, but you have to imagine the boat moving in as the winch pulls it. What is changing and what is staying the same? This is all about changing, right? The speed is a rate of change. So everything we're doing in this whole unit about related rates are about changes, rates of change. So you cannot look at a picture like that because nothing's changing. You have to look at that picture like this because things are changing. That 12 is not changing, which means that is constant. This distance right here is getting smaller. That is changing. That's changing is varying. That's a variable. So we need a variable to attach to that distance. Now look at the picture. Do you see how that's going to form a right triangle? That's where our math is going to flow out of this. So I'm going to call that, this is a variable quantity because it's changing. So I'm going to call that h for hypotenuse. This distance is never changing no matter where the boat is. So that's a constant. So I don't make a variable because it's not changing. This distance is changing. It's getting shorter as the movie progresses. So I have to name that something. Lack of creativity, let's call it x. So we have, see, everybody, I don't care how much math you took, sees a dock and a water and a boat and the rope. But only a person who's trained in mathematics starts to take a closer look and kind of overlay over the reality things that are true, right? This right triangle and these relationships, and we're analyzing what's staying the same and what's changing. That is not natural. Only someone who's trained in thinking this way, who knows to look for it, will do it. And that's what we're in the process of being trained how to do. And this is very important as you move forward in mathematics to think this way. All right, step one in one of these problems is draw a picture, because it helps you understand what's happening. And you got to know what's variable and what's constant. And you won't know that unless you think through the problem. Visualize it and make it real. This has to quit being book learning, and it has to be true, actual thought. You have to process what you are seeing. Make it real to you. If you can do that, then once you have this triangle in place, now you can let go of the reality and jump back into math class thinking. Now my math brain starts to take over. Okay, I have a right triangle. First thing I think of with right triangles is Pythagorean Theorem. So let's see what that looks like. X squared plus 12 squared is h squared. See, this is changing, it's getting closer. This is changing, it's getting closer. And this is not changing, it's always 12. Changing, variable. Changing, variable. Unchanging, constant. Those are the actual meaning of those words. How are you supposed to know what's a variable and what's a constant? By what they actually mean, right? Think about it. So this creates an equation. Step one, make a drawing. Step two, I skipped step two and went right to step three. Let's go back in time. Step two is extract all the information. So what do I know? All right, I know that's a constant, that's self-evident. So I took care of this number. What about this? That's not in the picture. I could put it in the picture. 4 feet per second towards the winch, right? But what do I actually call that? Well, isn't that kind of associated with this H, how much rope is out there? That's how fast the rope is being cranked in. So how fast, D something, and usually if you say how fast, it's over time, and it's related to H. So that must be dH dt. It's 4, and not, is it getting 4 feet further out, which it could be? That would be positive because H would be increasing. Or is it getting closer in? That would be negative because H is decreasing, negative. So that takes care of the 4. What is the speed of the boat? That's the question. Well, the speed of the boat, now we got to think about this again. If you were sitting on a boat, how would you, and you look down at the speedometer and it said like whatever miles per hour, kilometers per hour, would that mean how fast you're going in this direction or how fast you're going parallel to the water, right? Obviously, if I actually think about it, the speed of the boat is this idea. And look at the variable there. So this is asking, what is the speed of the boat? Based on the picture, it would be this. When the boat is 13 feet out, when there is 13 feet of rope out. So is that when X is 13 or H is 13? 13 feet of rope when H is 13. Step 1, make a drawing. Step 2, extract the given information out. Step 3, come up with an equation. 12 squared plus x squared is h squared. Step 4, take the derivative. The derivative of a constant is 0. 2x dx dt equals 2h dh dt. This is feeling familiar. Step 5, plug in your numbers. Oh, by the way, do you see how I could cancel the 2's out? I'm going to just do that. All right, when the boat is 13 feet, or there's 13 feet of rope, I actually don't know that distance, so I'm going to leave that blank. I don't know that yet. dx dt is what I'm looking for. See? So I don't know that. When there's 13 feet of rope out, and this is how fast the rope is being pulled, 4 feet, and there's 4 feet less every second. So this is my H, 13 feet of rope. This is how fast the rope is changing. I don't know how far it is from the dock at this point, and that's what I want to know. So this kind of shows me I got to figure out what this is. Well, what I'm trying to find out is what is this at the point in time when that is 13. That's a 13 out of B. So that's a Pythagorean Theorem problem. 13 squared is 12 squared plus x squared, so obviously x is 5 when you solve that. Hopefully you can see that. That's kind of faint. So at the point in time when h is 13, x would be 5. Now that's a pretty simple equation to solve. 5 dx dt is minus 52. So dx dt would be minus, looks like 10.4 feet per second. All right, so I want you to try some of these, and this is going to tie up our kind of remote unit on related rates. If you are having questions, please let me know in our Zoom meetings. All right, take care.